So let's begin. So first of all, what the character driver is. So if you remember, like in the last session, we discussed that we in all, if you look into the Linux driver ecosystem, we have three categories. We have three categories of drivers. One is what we call it as a storage vertical. Okay, storage vertical. Next, we have something called the networking vertical, and the another one which we have got is the character vertical. Okay, so this is what we have discussed. So storage vertical for the disk kind of devices, persistent memory. So be it like your pen drive, be it like your hard disk, be it like a CD-ROM. So this vertical corresponds to that. Networking vertical is again for the packet-oriented transaction, and character vertical is basically for the byte-oriented transaction. So that's why when I say character driver is something which allows the byte oriented transaction. That means the minimal accessible unit which you have, the minimal transactional unit which you have is a byte. And as we understand, typically in C, the byte, we refer it as a data type char, char. Okay, so that's why this particular term character driver. So driver which allows the byte oriented transactions, we call it as a character driver. Now, uh, as we understand in Linux, we basically have the philosophy, uh, which is basically the overall architecture. The Unix-like operating systems, they follow this architecture that uh, you have something called the system calls, and system calls will be the one which will help you transition to the kernel space. So of course we have the system calls like open, read, write, and all those kind of stuff. One thing which is common with this system calls is they all operate on file. They all operate, these all, whatever we have, these system calls we have, they operate on file. And this brings us to the important concepts in the Unix architecture, Unix like operating system architecture, that everything is a file. Okay, everything, be it your keyboard, be it your mouse, be it your uh, monitor, everything is basically treated as a file. So again, character driver is not an exception. Whatever devices which will fall under this character device category, they will also show up as a file so that user space can interact with them. So accordingly, if you ask me, if you look into this particular stuff over here under the dev is where your device files will be there. And under this, if we just grab for the files which we are which are basically having an attribute starting with C, you will see there are numerous files like that which has the first column as C. This means it's a character special file. So similarly, as we have already discussed in our earlier session, in Linux we have seven types of files. Okay, seven types of files. What are these? Regular files, directory, even directory is considered as a special file. Then you basically have something called the pipe special file, and then we have a character special file. Okay, and we have something like a block special file for the storage vertical, block special file. We have socket for the networking related stuff, socket special file. And next last one is basically the link. So how many? One, two, three, uh, four, five, six, and seven. So overall, you have a seven types of files in Linux, and one of them is basically the character special file. And over here, the C signifies that it is meant for the character device. Whatever driver you will be interacting with, it's basically a character driver. Okay. Now, if you compare this file Let's say I will take tty o0 for instance. Okay, and I'll take any regular file. For instance, over here I have this C file. So let's see what all differences and similarities we have between this regular file and the character special file. So of course, for the user space application, what you need is the name. Name is very, very important because whenever we use the open system call, the first argument which we provide over here is basically the name of the file. So in order to interact with a kernel or open a regular file, we basically need to have a name of the file. So this is very important from the user application perspective. Similarly, over here you see we have a name for this file as well. Another thing which you will observe is like there are something like attributes, which basically tells us like what all permissions are there, who all have the permissions, what kind of permissions on this file, read, write, execute. So kind of like you see, this file has the owner has read, write privileges, the others just have the write privileges, something like this. Okay, I think just okay. So now you see over here the difference between the attributes for this and this is over here you have got C and here it is blank. So that's how you can distinguish between the regular file and the character special file. Another thing which you will see is date of modification. In a similar manner, we basically have the uh, owner and the group. So over here also we have the owner and group. So from that perspective, you see it is uh, resembling this regular file. The character special file is resembling the regular file. But where does it differs is, you see in a regular file there is one attribute called size. But when you look into this character special file, there is nothing like size. We don't have anything like size over here. Instead, what we have is we have something called 4 comma 0. Now, what's this 4 comma 0? We will see that in a little while. But the important point which I want to make over here is, since there is no attribute called size for the character special file, that means this file is not meant to store any data. You should not be able to store any data in this particular file, because if it is able to store the data, then it should have the size. If there is no size, that means it's not meant to store the data. So what do I mean by that is, I can't do something like sudo, for example, vi slash dev tty o0. I open this particular file with vi. Now I opened it. Okay, so I'm writing something into this. Now you see, when I save it over here and I just check the size, doesn't show. Now if I open it, I don't see any data, and it says it's not a file also. Like when I open it, it says it's not a file. Okay, so you see, this is not a regular file where you will be able to, with vi we are getting this particular thing, slash dev tty0 is not a file. Okay, so that's the difference between your regular file and the character special file. Character special file is just a placeholder. The whole purpose with this character special files serves is to redirect your calls to the specific driver. Okay, so till this point, everybody is clear with this concept. If you have any questions, just let me know. Okay, great. So we'll proceed. Now, coming to the point, what is this 4 comma 0? So as I told you, from the from this particular application perspective, name is very important. Okay, name is very important. But when it comes to the kernel, in order for the kernel to identify the particular driver, name holds no importance. Actually, we don't don't rely on the strings when it comes to mapping a particular driver to the kernel, a particular character driver. What we basically use over here is the identification and mechanism we use for the driver is the something like a number. Okay, number. It's a 32-bit number typically, but we are not supposed to make any assumptions about whether it's a 32-bit or 64-bit or anything like this. But one of the convention which typically is followed in the kernel is this particular number is being split into two parts, something like this. So what we have over here is a 32-bit number which serves as an identification mechanism for the corresponding driver. And here what we do is we basically split this number into two parts, uh, 12 bits and 20 bits. Now why would why we would like to split this into two numbers, we are going to understand in a little while. So overall this 32-bit number serves as an identification mechanism. It serves as a link between the file and the corresponding driver so that the kernel can know which driver is responsible for serving this particular file. So when I say ls minus l over here, the this thing 4 comma 0 which we are seeing is the one which serves as an identification mechanism to connect with a corresponding driver. So over here what happens is 4 is here and 0 is over here. So least significant 20 bits says is basically 0, and first most significant 12 bits is 4, and this thing we call it as a major number, and this one we call it as a minor number. So this 32-bit number we split it into two parts, major number and minor number. Now comes the question, like, why do we need to split this particular number into two parts? So kernel developers basically had the thought like, if we just go ahead with a complete 32-bit number, uh, it will work fine from the driver writer from the kernel perspective. But let us basically put some standard around. That means like by looking at this particular number, I should be able to identify to which category this particular device belongs or particular device file belongs. So that's why what they thought was we'll split this into 12 bits. The first 12 bit, which we call it as a major number, they are basically to the category. So that means by looking at this particular number as 4, I should be able to, no matter whatever is the name of the file. Let's say right now it is named as slash dev tty0, it can be named as slash dev abc slash dev xyz, whatever. But by looking at this particular number, I should be able to identify that this will be redirected to the tty framework. Now what is tty framework? Tty framework is teletypewriters framework. That means all your console and everything operates on that. We don't need to go into the details on that. So here this TTY is a standard driver, and by looking at this number 4, I should be able to identify this device file corresponds to this, irrespective of what name you have over here. Okay, so that was the whole purpose. So major number corresponds to the category where it says to which category this particular driver belongs. Now, what is minor number? To understand the minor numbers, I typically give an example of a device which serves multiple functionalities, which provides multiple functionality. And typically I take the case of, let's say there is a multifunction hypothetical example. Let's say you have a multifunction printer. Okay, so this multifunction printer which we have, it serves to three purposes. What are they? They are basically printing, scanning, and then you have photocopying. Okay, photocopying. Now, in order to serve the three different functionalities, This particular device needs to expose, or I would like to say the driver for this particular multifunction printer needs to expose three different interfaces. Okay, so three different interfaces means three different device files. So for instance, what it will be exposing is something like slash dev pr slash dev uh, sc, for instance, slash dev ph. So if the application wants to do something called the printing, then it will operate on slash dev pr. If the application wants to do scanning, it will basically operate on slash dev sc, and photocopying slash dev ph. Okay, so of course I'm not going into the implementation that printer is implemented like that, but I would like, I'm giving this example so that you can get a better understanding of what do I mean by um, uh, this major and minor number. Now see what happens is, since this is a printer, what will happen, this is a printer kind of printer device, whatever driver which we will write underneath, let's say printer driver.c, printer driver.c, it will first expose, it will basically have some measure number. Okay, so let's say the measure number, the hypothetical measure number is 250. Okay, now for all the device files, the measure number is going to remain the same because the driver is same, the category to which they are corresponding is same. But what will differ is the minor number, 0, 1, 2. So over here, if I have a files for the printer, so what will happen is slash dev pr will have the measure minor number 250 comma 0, slash dev uh, sc will have the minor number 250 comma 1, and similarly slash dev ph will have a major minor number 250 comma 2. So you see, we have three different interfaces. The major number remains the same, the minor number changes because it corresponds to the functionality. So that's what is the significance of 4 comma 0. So over here, when you go to the tty kind of drivers, let's say I want to do the I do the ls on this particular stuff. So, sorry, ls minus l I will have to do to get the details. So you see, measure number for all of them is same. Okay, for TTY, of course, it's they are put it as 5, but otherwise 4 comma 0, 4 comma 1, 4 comma 10, 4 comma 11, 4 comma 12, everything continues like this. So that is what is the significance of this particular major minor number. That means exposing the multiple interfaces from the same driver. It is being done with the help of this.
Sir, why do we need multiple interfaces? Can we do it in a single interface also?
Yes, we can. But internally, you'll have to basically figure out what functionality the application is looking for. Okay, so for example, I do printing and scanning with the same device file. Then you will have to internally interpret. You will have to application will have to specifically tell this is what I am looking for.
Okay, sir.
Okay,
Okay.
okay. I hope you are getting my point. If I don't provide the multiple interfaces, then means somehow I need the mechanism to decode what does the application want.
Okay. Okay. Yes, sir.
Okay, but if you have a device file, separate device file, you see the operation is being done on this particular interface. That means it is scanning. It's like that. Yeah, so this is achievable and we can do that particular stuff. But again, it depends on the design.
If you do like that, the application will have different APIs. Like thing means if you implement everything in a printer or single file, then the
Yes.
application will have APIs. Like do any driver have APIs?
Yes, of course. So what driver will have to do is will have to expose those APIs. It will have to provide the document to the application where it will say, okay, if you want the printing, then probably when you write something, anything which you want to send, before that send me the command PR. it's a printing, for instance. Or if you are doing scanning, okay, send me the command that now I want the scanning functionality. Of course, it's all implementation, we can do that. So from the driver we'll have to explore, we'll have to basically provide that document to the application writer.
And sir, in a single, let's say in a single driver file, we can initialize multiple device files also.
Yes, you can. That is what the purpose is. That's why you have the multiple miners.
Okay.
Okay, so of course that is what the whole purpose of this whole explanation is. The single driver can provide multiple interfaces. Okay.
This we can define in a single file also.
See, that is what. See, first of all, let's not think from that perspective. Let's first think of the requirement. Okay, think of the requirement. What's your requirement? You want to serve the multiple functionalities, multiple device files. If your requirement is something like serving only a single functionality, only one file. So you are actually thinking other way around. What I'm saying is, first you need to understand what your device provides, what your device is capable of. If your device is capable of multiple functionalities, you will need the multiple device files. Now, again, it's not mandatory that you need the multiple device files. For instance, you can manage with one device file also, but then you will have to do the decoding. Okay, so I'm still not clear with your question. If you can just elaborate, I could explain you even in a better way.
No, sir, I got the answer.
Okay, all right, yeah. Okay.
Yeah, hello. I can see, like with the change in the minor number,
Mm-hmm.
the file name also getting changed. Is it the case all the times? Like
No,
no
no.
two files with same name can be existing, right?
Yeah, see, now here there is a catch. See, let's say one file I created over here, slash devpr, and the same slash devpr I created in the slash folder. Then you can have multiple names, right? But what I can do is the slash devpr which I have got, I can give it the measure number 250, comma 0. Okay, and whatever I have got over here, which I will create, I'll give it 250, comma 1. So you can have a same name at a different location, but you can have a different minor numbers.
Okay, got it.
Yeah, so in a single folder, of course, you will have a one file only. So that's a general rule which applies everywhere, right? You can't have two files with the same name in the same folder.
Uh-huh.
Sir, are
Okay.
these major number and minor numbers automatically generated, or does the user need to keep track of these numbers?
User don't need to actually know about the major minor number. User just cares about the name.
Okay,
Okay, he's just bothered about the name. So how they are generated and all, we'll discuss about that in a little while.
thank you.
Okay. Okay, so hope this is clear to everyone. So let me just summarize what we have seen. You have something called the system calls. Okay, system calls are open, read, write, seek, and all those system calls we have. Okay, now these system calls they operate on file. This is where we basically know that in Unix everything is a file, be it a printer, be it like your mouse, keyboard, anything, everything is represented as a file. So character driver is no exception. This character driver, if you want to interact with a character driver, you basically need the character special file. Character special file. Now, character special file, if you want to find out what all different character special files I have in my system, what you need to do is, for instance, whichever file has the attribute first at the call first column sc, those are character special files. Now what we saw was, what is the difference between the character special file and the regular file? Most of the things are similar, like you have a name, you basically have a date of the creation modification, you basically have the attributes, basically have the permissions like user, owner, group and others, you basically have the owner and the group, and all those things remain the same. Majority of the things like name, access time or modification time, and then basically something like your owner and the root, o- owner and the group and the permissions, everything remains the same. But where does it differs from the regular file is that regular file has something called size. But when it comes to the character special file, you don't have the size. What you have is 4 comma 0. So any file which doesn't have the size as an attribute, that means it is not meant to store the data, and it serves the purpose of the placeholder. So then we discussed about why is this split of 4 comma 0. The split of 4 comma 0 is something like the measure number which corresponds to the category, which defines the category of the driver under which category this particular device file falls, and this minor number corresponds to the functionality. So that's what we have discussed so far.